of chapter R, the review. So this is natural log. So can anyone simplify the square root of e to the sixth? We said that the nth root of a to the mth power is a raised to which power?
Oh.
Say it again.
1/6. Oh, wait, 2/6.
So let's review it and then we'll go back to it.
That's 6/2.
Yes. So it's m over n. So the index is always the denominator. Awesome. So then how much is 6/2?
3.
Very good. So e to the third. Which property applies now? The power goes in front as a factor, which is 3 natural log e. And this is it. Now, natural log e, let's say we don't know what it is. We can calculate it, but I would like to show you something here. We can put in the calculator, but I don't want to. You can. So, natural log e is a number. I don't know this number. But I know to convert this, because we just wrote this. Any log equation can be converted into an exponential. So, what is the base of natural log? I don't see any base. What is the base? It must have a base. What is the base?
Is it a 10?
The 10 is for log. What is the base of natural log?
1.
There is no base of 1. Remember we said this here. The base can never be 1, can never be 0, and it can never be a negative number. Let's go back. Here it is. Why do you think that these two are together? If they are inverses of each other, they have to have the same base. Why do you think that these are together? If they are inverses of each other, they have to have the same base. So what is the base of natural log? Furthermore, we wrote it here.
E.
Exactly E. Thank you. The base must be E. We don't write it, but it's E. So E to this power equals E. This to this power equals this. Counterclockwise, starting with the base. B raised to y equals x. So E raised to this equals E. What could be in that box? What could this be?
1?
I meant to write 3, of course, not E. Yes, please remember natural log E is 1. And by the way, what do you think common log of 10 will equal to?
1.
Exactly. What do you think that log base 1/2 of 1/2 will equal to?
1.
Exactly. So log applied to the base will always be 1. Good. Moving on. Where is my book? Okay, so let's look at an exponential equation. Anyone would like to choose the exponential equation you want to solve? Again, this is just review from the previous class.
$45.
45, perfect. So in 45, we have e raised to negative 0.02t equals 0.06. Awesome. Good. So this is e to a power, and this is a number. If I have, let's say, 2 to the third equals 2 to 4 plus x, what will you say we should write?
We would just write 3 equals 4 plus x.
Absolutely, because the bases are the same. So 3 will equal 4 plus x, so x equals negative 1. Done. Excellent. Thank you. But here, e and 0.06 are not the same base. I cannot apply this simple concept. Same base, powers, and equal numbers, powers have to be the same. No, here I have to apply natural log to both sides. It's like applying the limit to both sides. It's like applying the square root to both sides. I'm applying the same procedure to both sides. Here's a question for you. Why don't I apply log? I chose to apply natural log. Why?
Is that because we have e on the left side?
Exactly. And because I know that this is also base e. And how much is natural log e then?
1.
1. So I simplify the equation a lot. Will I get a different answer if I apply log? No. I will get the exact same answer. But I have to apply log, common log, to both. Not here natural log and here common log or something else. It has to be the same function to both sides. Awesome. So now I know that this power goes in front as a factor. And again, I'm going to ask you, how much is natural log e? So what should I write? Times what?
1.
Yes, I'm not going to write it. Natural log of 0.06. Perfect. How do I solve for t? What do I need to do to both sides to solve for t?
Divide by negative 0.02.
That's it. Make sure you don't write something like this. That would be incorrect. See the difference? I'm dividing this number, which is at the top, by this number, and I put the minus in front. You can put it here if it confuses you, that's fine too. But please do not separate. This is one number divided by this number. I have no idea what that means. Nobody does. So I have natural log 0.06, close the parenthesis, and divide by, in parentheses because we start with a negative number, 0.02, close. This is a negative number, this is a negative number, the answer will be positive. 140.67. So t is 140.67. Good. Oh, I didn't mean to stop sharing. I need to go back. Very good pick. Now, something like this, you will have to divide both sides by 200 first. And then apply exactly what we just did together a minute ago. Let's choose a domain. Very important. This is not a friendly function. Log is not friendly. I have to worry about it.
Can we do 59?
Of course. 59. We have y equals natural log of x squared plus 1. So let me refresh our memory by comparison. When we had the square root of x plus 1, to find the domain of this, you can say it's not the same function. Yes, I know. I'm just comparing for a moment. How do I find the domain of this function? What do I have to write?
That x plus 1 is greater or equal to 0.
Excellent. In the same way, here, I have to write that x squared plus 1. However, it's only strictly greater than 0. How come? How come just strictly? Let's take a look. Zero to infinity, because that's the range of the exponential. So it cannot be 0. So by comparison, please remember the square root can have 0 under it, unless it's something like this. For such a function, I still have to write only greater than 0 because it cannot be 0 in the denominator. But here, this quantity that natural log is applied to can never equal 0. How come? Yes, look at the graph. I could never plug in 0 in log. Cannot plug in 0. Negative infinity. Cannot plug in 0. Positive infinity. Cannot plug in 0 in log. However, this is nice, because this is always true. So it happens that for this function, the domain is everything. How come? Yes, plug in here any number. You will have to square it plus 1. It will always be greater than 0. This is the only function, only type of function of log function that I don't worry about it, because this is always positive. A positive number plus 1. Always greater than 0. So this is the only one whose domain is all real numbers. Awesome. Let's see if we want to pick another. If not, we'll move on to equations, log equations.
Could we do like 57?
Yes. 57. You have g of x equals natural log of x plus 2 plus natural log x. Very good pick. Thank you. Perfect. So this is a sum of two functions. So let's look at the first one and tell me what condition I have to write. For this piece to exist, what is the condition that I have to write?
X plus 2 has to be greater than 0.
That's it, of course. For this, x plus 2 has to be greater than 0. Now what about for this?
X is greater than 0.
Absolutely. Very good. So for this one, x greater than 0. Now I have to intersect. Because I'm not interested in this piece. I'm not interested in this piece. I'm interested in the whole thing. So I have to intersect these conditions. This one means greater than negative 2. I have to move 2 to the other side. So let's intersect them, because both pieces have to exist for this to exist. So let's see what happens. I'm on page 7. Okay. The first one, greater than negative 2. So let's say this is negative 2. Greater than negative 2 means this. For this one, I have greater than 0. Okay. What will be the domain of G? So that both exist at the same time for G to exist.
Would it be 0 to infinity?
Absolutely, where both colors exist. The green and the purple or brown, whatever I have here, I don't know what this color is, I have no idea, burgundy. So burgundy and green together. If I choose a point here, the first function exists, but not the second one. If I choose a point here, none of them exists. So I have to choose exactly where I see the burgundy and the green together. So that's the domain of G. Awesome. Thank you. Let's look at a log equation before we look at applications.
Could we do number 68?
Yes. So let's look at 68. 68 natural log of x plus 2 plus natural log x equals natural log 24. Now, whenever we solve logarithmic equations, we have two methods that we can choose to use. You don't have to stick with one of them. You can change from one problem to the other. But I prefer stating domain. You may say no. For me, it's too much work, but I promise to check. You have to either state the domain, and of course, use it, or promise to check whatever you get. For one problem, you can use this method. For another problem, you can use this method. It's up to you. I will use this one. Why? I'm lazy. I don't like checking. I like to state the domain. And I may forget to check. But if I state the domain, I will not forget. So, again, can anyone give us, since we chose the same thing, luckily for me, we chose the same function, we already have the domain. I don't have to do it again. It happens that we have exactly the same function you picked a minute ago. So I know that this is the domain of this function. So if I get an answer, after I solve the equation, if I get an answer that is -2, will I accept it or not?
You wouldn't accept it?
Because it's not in the domain. Of course I will not. And I will say the equation has no solutions. But what if I get x equals 1.3? Will I accept it?
Yes.
Yes. And I'll say I'm done. I don't have to check. I trust my work. You can say, okay, I trust my work, but I still want to check. That is safe. And I recommend it. Okay? Good. Now, in order to solve this equation, I have to condense this. Condense? Yes. So going back to the rules that we listed a minute ago, these go back and forth from here to this side and from this side back. So I have a sum of two logs with the same base. I can condense it and write this. Same thing here. They go back and forth. They're dynamic from here, here, and back. Of course, here as well, from here, here, and back. So now let's condense. How do I condense this? I have a sum of two logs with the same base.
It'll be ln x plus 2 times x.
That's it. Equals natural log of 24. So now I'm going to say this. See, my props are extremely valuable. This log equals this log. What has to happen to these quantities for this log to equal this one? In other words, I'm saying, can this be 5 and here 100?
No.
No, that's not possible. So what has to happen then for log of this to equal log of this?
It has to be also 24.
Yes, this one has to equal this. So x times x plus 2 must equal 24. What type of equation is this and how do I solve it?